Okay, in the next panel, we will discuss and find out the best practice to get started with enterprise AI. Now, I would like to invite the moderator of this session, Ms. Jessie Chen, CEO of GLORIA NCKU, to the stage. Listen, I'm so sorry, Mr. Chen, CEO of GLORIA. And our panelists, Mr. Alessandro Gasparini, Executive Vice President and Chief Commercial Officer of ImmerVision. And Mr. Handol Kim, General Manager of Quadrant. Last but not least, Mr. Casey Ye, Head of Group Research and Innovation Center of CTCI. Mr. Chen, it's your time.
Good afternoon, everyone. I think in the next 15 minutes, we are in for a treat from these great speakers that we invited. Let's again allow a few minutes for each one of them to introduce themselves. Let's start from you, Alessandro.
Hi, everyone. I'm Alessandro Gasparini. I'm the Executive Vice President and Chief Commercial Officer at ImmerVision. ImmerVision is a company focusing on enabling intelligent vision for any machine and to bring humanity to those machines. And I will be happy to share some of our work and some thoughts with the rest of the panel.
Okay, thank you, Alessandro. Handol.
Hello, everyone. My name is Handol Kim. I'm the General Manager of Quadrant. We are a generative machine learning business unit of D-Wave Systems based in Vancouver, Canada. D-Wave Systems is a quantum computing company, and we employ cutting-edge energy-based computation methods to solve previously intractable machine learning problems.
Casey?
Hi, how are you, everyone? My name is Casey Ye. I'm the Chief Research Officer at CTCI. CTCI, Zhongding Jituan, is one of the largest construction company in Taiwan, and it's also one of the top 100 company in the world. So very nice to have the opportunity here to talk to everyone.
Yeah, this group of the people is one special talent I just realized when we were back there talking. Actually, among the group, we speak Chinese, Mandarin, Japanese, Korean, French, Italian, and of course, English. So, which language will you guys prefer? Let's start with, again, Alessandro. Again, why don't you give us your story about ImmerVision?
I will stand up. I prefer to move around. I will present how AI-ready data in picture technology powers advanced application for consumer and the professional sector. So very quickly about ImmerVision, we design wide-angle lenses with augmented resolution and advanced image processing technology for increased image quality. The company was founded back in 2000, and we, at that time, developed a new optical technology called the Panomorph. And from that moment on, we've been designing wide-angle lenses ranging from 80 degrees field of view to over 240 for multiple application. So on top of that, we have been designing some image processing technology that, combined with the lens, allow to do calibration, dewarping, some stitching, image stabilization, sensor fusion, and all other type of specific image application processing. We are based in Canada, employing optical designers and also image processing engineers. They're working hand in hand together, developing some of the most advanced imaging system for a variety of industry. We have a portfolio of patents that covers both optical technology and image processing, and we license that to our customers and partners. So we have a global network of them from professional application, consumer devices, automotive, robotics, security, and aerospace and medical application are some of the industry where we focus on. So I would start by saying that, vision is the human most important sense. And, but the thing is, the way human perceive requires all senses to work together at the same time. So for machine, today the challenge is actually to synchronize all the sensors together in order to provide that like human perception. And that to feed the AI system, deep learning, and the computer vision. So often people, when we talk to them, we say, hey, you hear a sound, the first thing you do, you look where the sound's coming from. You smell something good, you look where it's coming from. You touch something that it's a funny feeling, you're going to look at your hand. And sometimes you eat something and you go like, what is this? And you watch. So vision is a validation of everything. And so one of the challenges is how we combine that with all the other senses for the machines. So for example, when we're talking about bringing all of this together in a machine, we're talking about fusing the sensor. And in the case, what we bring is a technology that allows to bring all of that sensing embedded inside the pixel, so inside the image. So that in picture combines all the sensory data derived from different sources in the video pixels and dynamically synchronized with each video frame. So the resulting information has less uncertainty than will be possibly when these resources were used individually. So if you look at this image here, what you have is you have a number of different sensors: pressure, compass, lenses, light, microphone, GPS, gyroscope, and all of that data will find himself synchronized and marked inside the pixel of the image for every frame. The data in picture has been developed to solve legacy video metadata pain points. So technically, live data in picture technology helps solving those issues that mainly are caused by consistency, synchronization, live streaming, and multi-platform support issues. So for example, live data in picture is persistent and reliable. On each frame, you're going to get all the data. You change the file format, and again, you still have all the data inside the pixels. It's synchronized and dynamic, so all the data coming together from the different sensor is there in that pixels. Also, because the way it's processed, it's going to consume less power, because everything being on the picture doesn't require to be supported on multiple different devices, all synchronized together. And of course, contextual, because it supports different type of sensors that gives you a better idea of the, let's say, of the environment of that image was taken. I will move on to one important element, is the foundation of the AI pyramid of needs that data in picture solves. If you look at this pyramid, you see that the AI at the top, what it requires, it's at the base is the data. And I've been hearing that often: data, quality of data, reliable data, data that can be used to train the systems, and data that then is going to be able to drive the system, like in autonomous driving or robots. So that's where we see the collect and the storage of the data at that level. That's where you can actually make better use of data in a picture. So smarter data for AI, computer vision, and deep learning. So we see the machines, we provide perceptions, we provide with the wide-angle vision, gas sensing, spatial sound, orientation, temperature, time and location with GPS, for example. All of that information coming at the same time with the capture of the vision of the system, like in, for example, stereo and 3D. So the sensors are, we collect the sensors, devices, user, and external data all together. The data in picture library then will aggregate and compress and encode all of that information inside those markers that you see in those images. And on each frame of the video embeds that deep data in picture, dynamically synchronized for the machine learning inference or for data collection. So some example of how you can use that for in wide angle, for example, imaging. You can actually take a sports cam, which having a lens, accelerometer, compass, the CMOS, gyroscope, and GPS data all synchronized on each frame of the video. Then, by knowing what is exactly the distortion of that wide-angle lens, I can apply some algorithms in real time to make that image flat. But at the same time, I can use the information of the gyroscope and the compass to stabilize the image electronically while I visualize it. In addition to that, I can also have some information about the timestamps and all of that inside the image. I could take those videos then and feed them to the AI system, and the AI system will be actually able to know more than a human because it will know exactly where those pictures were taken. It will know exactly what was the speed, what was the angle of the camera, so it can actually better understand what he's watching. Another example would be in automotive, and you will have a number of other sensors, including even the driver behavior, the speed, and the different cameras coming together. Combining all of that information, once again, will be helpful for the autonomous driving, for example, to be able to understand what he's watching, what he's seeing from different angles, and be able to address look at the image coming from a specific camera for a specific function. And another example, which is very popular in terms of VR processing, the data allows to have a simultaneous user watching the same video, different angles, and in this case here, it will allow the users to only, when they look at a certain area, their head-mounted display, only to process the information coming from that specific area. And when they're watching the area where the two images come together, only then processing that stitch together those two images. So again, this is a way where this data in picture can come to enhance the information captured during the filming or in real time, and be able then to facilitate and enhance the experience of the end user. So I hope this gave you an oversight of how this technology can come and help AI system, deep learning, and machine vision, and we'll be glad to answer some questions later on. Thank you.
Thank you, Alessandro. Now it's your turn, Handol.
Thank you, everyone. Thank you, Jesse. Thank you, Alessandro. Hello, everyone. How are we doing? Good? Just quickly, who here would consider themselves AI experts? All right. Who here believes that AI is about Terminators and Skynets and robots that will take your job? Okay. All right. Well, you're not wrong. No, I'm joking, of course. Today, my talk will be about beyond deep learning and the need for generative learning. Do people here understand the difference between AI and deep learning? No? Okay. That's not surprising because they're often used interchangeably. My rule of thumb is that AI is not really a technology. It is an industry designation, like semiconductors, right? So if you say we use AI in our business, it's like saying we use semiconductors in our business. It's vague and it's a technology sector. It's not a specific technology. Of course, there is a specific AI technology that's called artificial general intelligence, but that's science fiction and that's all about Terminators and Skynet. But in general, in the field of AI, we use the term machine learning. And in machine learning, there are several varieties, the most popular of which is called deep learning. And today, I'll talk about deep learning and its limitations. But first of all, who are we? I represent a business group called Quadrant. We are the machine learning business unit of D-Wave Systems. We are core AI. We develop algorithms, core AI algorithms that we then implement and license to enterprise customers. Why we do it? Well, we focus on generative machine learning, which is a type of machine learning that is somewhat distinct from deep learning, and I'll go through the difference. And finally, where we apply it. Today I'll talk about two use cases, one in medical imaging and the other in telecommunications. So first of all, who are we? Well, our parent company is D-Wave Systems, and as you can see, we were on the cover of Time magazine. We helped Thanos build an infinity gauntlet. sorry, Infinity Machine was the title of the article. We are the only company to have actually built, shipped, and serviced a real quantum computer, and we've sold those to Google, to NASA, Los Alamos National Labs. We've also provided remote access to companies such as Volkswagen, Nomura, and Toyota Tsusho. So Quadrant is the business unit that specializes in machine learning. We have machine learning researchers who have authored or co-authored over 100 papers and presented at conferences such as NIPS, iClear, ICML, etc. We know what we're doing. We have a world-class team based in Vancouver, and we deliver solutions and try and democratize cutting-edge machine learning for enterprises. So our thesis is very simple. Our thesis is that all of the excitement around deep learning, or around AI, as many people call it, in the last few years has resulted from basically backpropagation and the use of deep learning in solving computer vision problems. Okay? That's primarily what's driven the intense interest around AI. That is, of course, not indicative of the entire field of machine learning, but that's certainly something that has driven the intense interest. But the fact of the matter is as awesome as deep learning is, it has limitations. Some of the limitations are very well known. One is that the real world is not full of high-quality data sets walking around that you can use. All right? They don't exist. Often, you are approaching a problem and it's not a classification problem. You're not trying to detect A from B. All right? There are different types of statistical problems that you're trying to solve in machine learning. And then often, the very nature of the data sets that you're trying to work on defy deep learning. They're either very high dimensional or have high class imbalance. Okay? So if we want to actually apply machine learning to applications that are outside of autonomous driving or determining if there's a cat in a photo or not, or various other computer vision-based applications, we really need to think of machine learning as a toolkit rather than as a single tool. And the toolkit has many, many tools, whether it's reinforcement learning, or generative learning, or transfer learning, et cetera, et cetera. And of course, this may be beyond sort of the technical level of many of you in the audience right now, but just remember that deep learning is not all there is to machine learning. Generative learning is one of the approaches that we specialize in at Quadrant, and I'll explain what it is that we do and why we do it. Okay, so this quote is very indicative. It's from Andrew Ng, of course, the former head of Baidu AI and also co-founder of Google Brain, and all-around, AI stud. And he had a metaphor that's very useful to think about, which is, he said AI is like a rocket ship. And if you want the rocket ship to launch, you need a very big engine, and you need a lot of fuel. That engine is your model or your algorithm, and that fuel, and I've changed it, is labeled data. Everyone talks about big data, and I like to say, look, your data is not as big as you think it is. Okay? When it comes to machine learning, you need labeled data. If you don't have labeled data, it gets very, very hard. And it gets very hard for for deep learning to make any kinds of heads or tails from it. Okay? Also, one of the reasons why deep learning is so good and it's so popular, especially in the digital field, is that the performance and the accuracy scales with the amount of data that you feed into the model. So the more data that you can feed in, that you can ingest into your deep learning model, the better the accuracy. Okay? Now, if you look at other older sort of learning algorithms, I don't know if I have a pointer, things like random forest or support vector machines or various other techniques that people who have been in machine learning for a lot longer have used, they don't necessarily scale in performance with the amount of data. However, at Quadrant, with the generative, what we can do is get very good accuracy and performance with small amounts of data. And where we really shine is, where generative learning really shines is in the existence of small data sets. When you don't have a lot of labeled data as a percentage of the data set that you're trying to classify or generalize to. Where you have labels that are messy or noisy. So if any of you have actually worked in machine learning, a few mislabeled samples can completely throw off the accuracy of your model, because your model will try and fit to that. Okay? And especially in other generative approaches such as GANs, where you have class imbalance, where you're trying to detect anomalies, for example. If let's say in a credit card transaction data set, 0.1% of your transactions are fraudulent. Well, a deep learning model might generalize and say everything is good, and you get 99.9% accuracy. So in class imbalanced data sets, it's very difficult to use deep learning, as well as with unlabeled data. And this is a very interesting use case where sometimes you have data and you don't exactly know what you want to classify. And this is very important in bioinformatics, for example. This is very important in various areas. There was a famous Nobel laureate, an economist named Ronald Coase. And he had a quote. He said, "If you torture your data long enough, it will confess to anything." Okay? So if any of you have actually worked in statistics or machine learning or data science, you know exactly what that means. If you've ever written a graduate level paper, you know exactly what that means, right? You try and fit your data to get the best results. But sometimes the data has a story that you don't know a priori before you start interrogating it. And in that sense, using an unsupervised method to understand the structure, the inherent data that is there, as well as the data that's not there, in sampling from the latent space, can yield very, very good performance. And that's really our specialty. So finally, our business is basically we engage with customers. They provide their data. We provide our algorithms. Together we work, and then we give them the results. And very important, we don't need a quantum computer to do this. We run on standard GPU and CPU. So our use cases are, one, we did a project with Siemens Healthineers, where we won a global machine learning challenge that we used 50 training videos of cataract eye surgery. This is the most commonly performed surgery in the world. We had 50 videos, and we had to basically annotate 21 surgical instruments. So we won that. We got 99.71% accuracy averaged. And so we effectively solved that problem. That's very important in enabling computer-assisted interventions, which is for automated surgeries down the line. The other use case that we're able to discuss is that we apply advanced machine learning to self-organizing networks in 5G networks. And we're currently in advanced discussions with mobile network operators, because as you may or may not know, 5G will require machine learning, and it will require SONs. And so that's an area that we're working in. Okay? Thank you very much.
Thank you, Handol. And it's good to know that, again, AI is not Terminator, but rocket ship, right? Now, Casey, it's your turn to tell us your story.
Thank you, JC. 大家好，我是叶启信。So it's really nice to have the opportunity here to talk to everyone. Before I come back to Taiwan, I worked in Silicon Valley for 30 years. And I was in the software product company. So I guess probably most of you today here are making product and trying to sell your product to find the buyer, which I was like that before. So we have product and we are trying to find the buyer to solve the problem for them. But now I'm back to Taiwan and taking on this new job at CTCI. CTCI is a general construction company. So we build factory, we build oil refinery, we build a power plant, we build pretty much everything, any building that we do. And CTCI is one of the top 100 construction company in the world as well. We have about projects in 15 different countries. So CTCI is a global company. We also have 3 different business groups. The first one is the engineering business group. And this group, what we do is we design and we construct a factory building for our client. We also have an intelligent business group, which we built the intelligent solutions to help our customer to optimize their operation, their maintenance. And then we have a resource recycling group, which we help our client to improve the environment to save the world. So you may be wondering why I'm here today. Because in this industry, which is a very classic industry, compared with many of you probably familiar with manufacturing, with the healthcare, which we talk a lot about today in this event. But construction is a very traditional, and in many ways, we are behind the curve in adapting the new technology. So there is a lot of opportunities if you have the solution to solve the problem that we have. So I'm going to share some of the challenge that we have and also tell you some of the opportunity that we see. So in this construction industry, you can see that, well, if we can only make some minor productivity improvement, we will be able to create $1.6 trillion of value, saving the money, which can be reinvested into other things. So there is great opportunities that we can find the solution for many of the challenge that we have. And because of the Industry 4.0, because of these digital disruptions that we all talking about, there are many of these technologies that can be applied to solve the problem that we have. And of course, AI, machine learning, this is one of the a major driving technology that is going to help move into the next generation. So there are a few examples that I would like to share with you today. The first one is engineering information discovery. Some of you probably heard about this already in the legal technology or financial technology. We're going to share with you some of the challenge that we have. And we can talk about the engineering design automation as well. Safety and security, and inspection and progress. So these are the different major areas that we have that we will need to find solution to help us to get that productivities up. So first one, engineering information discovery. So what we're talking about here is, in a typical project, when we first start a project, we will receive hundreds, if not thousands, of engineering technical documents from our client. And those documents will be on the paper or in some form of PDF file, Excel, whatever. And what it does is it takes hundreds of people, engineers, well-educated people, to read those documents and find the information that we need so we can begin to use those informations to understand what is the requirement and how we're going to build the project. And this whole process takes months with hundreds of people. So what we really need is we need to find a way that we're able to find those information that we need from the oceans of documents that we have and trying to make sure those information that we have are accurate and does not conflict with each other. And so a lot of the technology that we have to rely on are like natural language processing. So we can read the document that contain those information, like finding what is the temperature spec of a furnace and what is the size. And all this information could be scattered in different documents. And we also need to read the diagrams that we need to understand what are the valves, what are the pipes, and what are the properties of those valves and pipes. And those information, typically you read it, people have to read it and then copy it down onto a paper. We would like to find a solution to automate this. And what we have been doing is we have been looking at the natural language processing. We have been looking at the object recognition to help us to parse all this information that we need. So this is one area that we have been working on. Another area is the engineering design automation. Once we have all this information, it takes also a lot of people to interpret those information and begin to create the engineering drawing. And a lot of the time, those people will, based on their best knowledge, their experience, to create the diagram or the design. And many times, it's only limited to what the persons know. So what we would like to do is we would like to automate this process. And not only that, we are hoping to use the generative design idea, which we can generate a lot of the design, a lot of the options, where then we can find what is the best one that can be applied to our problem. So this is also an area that can do a lot of the optimization, and also the AI machine learning can help us to liberate our imagination on a lot of this kind of design. The next area is the safety and security monitoring. So safety and security is the important elements in the construction industry, especially at the construction site. So we need to watch out for whether people are working in a safe condition and whether there's any dangerous movement, like the equipment, the crane operation, could be causing any safety problem. And it is very difficult to monitor and control all these kind of things. But now we have drone, we have video, we have robot that can help us to patrol the construction site and able to capture all those information and send it back right away to detect those kind of conditions so we can prevent those dangerous or unsafe situations from happening. So this is one of the area. The next one is the inspection and progress tracking. So in today, people has to go to the site and manually inspect everything. What we would like to do is we would like to able to automate this process with image capture, so we can compare the 3D models of the construction and able to tell what are the progress that we have made on the project. And this is also a lot of technology that has been applied. And so we have been very actively working and applying those kind of technology. So those are the 4 different areas that we have been looking at. If you have any solution, we will be really happy to talk to you. So in the future of the engineering and construction, what we have been talking about is we need to be digitally connected. We need to be data-oriented. Data is the key. And then this can all be powered by the AI, so we can create that future that we are looking for. Thank you very much.
Thank you, Casey. Before we start the Q&A session, I'd like to survey the audience. How many of you are in the AI industry? Any? How many of you, again, are in AI industry 3 years ago? Nobody? Okay. So the good news is that it's not too late, right? It's not too late to join the game. And the key thing is that Taiwan is looking for a solution into the future, and we point AI as a direction. So one key question like to ask our panelists, again, obviously Taiwan has a very successful industry in semiconductor. TSMC is our gold standard. So how do we create a TSMC in Taiwan for AI? Anyone?
Okay, so if you believe that AI is a critical technology and close to a zero-sum game, which means that whoever wins first gets most of the benefit. And if Taiwan really wants to make AI a national priority, then I think you need to do something like what Taiwan did in the late 70s when it created Hsinchu National Science Park. Is create a program where you attract Taiwanese who are currently at leading companies like Google, DeepMind, Facebook, etc., who are premier machine learning researchers to come back, give them a whole bunch of money so they can start companies, and give them a tax holiday and access to as much GPU from NVIDIA as possible, and really aggressively bring these people back. Because if you have a PhD from CMU or Stanford or Berkeley, you can walk into a job in Silicon Valley at $500,000 starting salary, and that's base. That's not counting restricted stock options, et cetera, et cetera. So how do you compete with something like that? Is you have to make it a national priority, and you have to open up the purse strings and bring people back. And that, I think you have to get aggressive if you believe that AI is a critical technology. That's what we did with TSMC and UMC and these companies back in the late 70s. Maybe you could do it again for AI.
Thank you. Alessandro?
I've been seeing that there is already some initiatives that the government have launched to get the academia closer to the industry. And I believe that a lot of the success is going to be there. So to really get those initiatives of projects driven by industries and work together with the academia to find those solutions. So we were talking, there's a lot of problems that needs to be solved. Let's work together, industry and academia, and certainly do not silos the activities, but really cooperate in this field.
Well, in order to become the next powerhouse of the AI industry, I think it is very important that we have talent, and Taiwan has talent. I think Taiwan, we have a lot of really smart people. We have very good education that built a very good foundation, and these are the value that we can provide. So I think it is very important that if we're able to find the right direction, we do have a lot of capital that we can build on. So I'm hoping that this will be something that we can all work together.
Thank you. Now I'm open up for questions from the audience. Yes?
Hello, my name is Jason. So to get a total solution for AI, so we know that there are three important components: hardware, software, and the cloud platform. Which one do you think is most important? And how much percentage should we put more on that part?
Anyone to jump in?
I think software is the most important. Do you mean developing hardware? Because there are options from GPU, CPU makers, and then there's TPUs that are available. So you can make use of commodity or special purpose hardware. There's not, aside from neuromorphic or TPU or new generation ASICs that are specifically optimized for neural nets or deep neural nets, there's not that much in hardware. In cloud, here's the thing: is we work with a lot of enterprises. Enterprises don't want to run their models in a cloud. They all want to do it on-prem. And if you do a machine learning as a service, you're not going to succeed. I mean, that's where IBM and Google and Microsoft, all those guys are living. So if you're not one of those people, then you really don't have a chance to innovate. Where you need to innovate, I think, is in software. Because AI is software. Everyone uses robots, but that's misleading. AI and machine learning is all software. So that's where you have to focus.
Thank you.
Well, I agree. And at the same time, AI can only work if you teach it. So to teach, the system needs to learn, and to learn, it needs data. So one of the big requirements, it's really good, reliable data to help the system grow its knowledge and understanding and be more accurate in its predictions. So this is also an area that it's important. And one thing that we've been seeing, yes, software being a key part of AI, a lot of company working in developing the software, working on the principle of the algorithms, but also one thing that we found traveling across the world, a lot of software developers, but do not have enough reliable hardware to capture the data. And that is one also of the areas that certainly would be an important focus to help developing more and more applications.
So I think it is, certainly I agree, software is important. But I think one of the big challenge that we're facing today with AI technology is it is so hard to use. You need to be a data scientist, you need to be a mathematician, you need to be a software developer, and you probably need to be the combination of all this in order to use the AI properly. So it is really important if we want to liberalize or this power of AI, we need to have the tool to be able to help people to use it. And to build the tool, I think a lot of the opportunity that we have there will be in the software side of the work. So that's my view.
Well, being from Silicon Valley, actually 3 of us used to live in Silicon Valley, and this guy goes there all the time. I'd like to take a different take on that one. Again, I think hardware, software, or cloud is all secondary. The most important part is to define the problem, define the parameter, and define what you want to achieve first. Otherwise, again, you will get misled again into a corner that may not even be the right direction. Just one suggestion, again, you may want to cut in a little bit different. Again, my answer is kind of tricky, right? Again, Silicon Valley never answers the right question right on. We always go around and then cut you off. So at this point, I'd like to say that the time is out. And thank you guys again for an all-star cast. And enjoy the rest of the show. Thank you, guys.
Thank you, Mr. Chen, our moderator, and our panelists.